Welcome everyone to today's webinar from Fiber to Intelligence. As we navigate the era of AI, the rapid evolution of data centers has become undeniable. At the heart of this transformation lies fiber connectivity, a critical backbone supporting the high density, high performance demands of AI-driven operations. In this session, Panduit will guide you through how advanced fiber infrastructure plays a vital role in optimizing data centers for AI applications. This webinar offers actionable insights into structured cabling and connectivity solutions tailored for the AI era. Today's presenter is Mike Compton. Mike is a senior solutions architect that has spent over 25 years in the technology industry with a focus on the data center marketplace. In his 12 years at Panduit, he has produced architecture guides around key data center technologies to enable successful customer deployments for connectivity installers to Fortune 100 companies. Mike's focus is on value-added solutions that solve customer problems related to technologies such as converged infrastructure, high-performance computing, and AI applications. Mike, I'll hand the call over to you now.
Great. Thank you, Kelly, and good morning, all. As Kelly said, I'm Mike Compton, a senior solutions architect within our Panduit Data Center Fiber Group. I'd like to speak to you guys today about some AI trends and insights we're seeing in the marketplace today. So our agenda for today is who is Panduit, first of all, and then we'll give you some current and some future AI trends that we're seeing. Also, what does AI cabling plant look like after all of these trends are gone through in the marketplace? And then lastly, how can Panduit help you with your AI journey? Panduit approaches our business differently because we're a unique company. As a privately held company, Panduit has freedom to make decisions that meet our customer needs. Our business model is focused on earning customer preference, and our commitment is to cultivating long-term customer partnerships that deliver business value. We offer the most comprehensive product line in the industry, and we leverage and apply the latest technologies to manufacture solutions that create competitive advantages for our customers. Here are a few things I'd like to highlight about Panduit. Like I mentioned, we are a privately held company, which means we're not tied to shareholder returns. With that in mind, we place a large emphasis on research and development to ensure that we bring the latest and best solutions to the market. We're also a top 3 connectivity provider. You will see our name on many customer specs as an approved vendor. And lastly, Panduit products and solutions are in 90% of the Fortune 100 companies. As a trusted manufacturer of data center components, these high-profile customers trust Panduit to run their multi-billion-dollar companies on our solutions. Now we're going to talk a little bit about trends that we're seeing in the AI marketplace itself. So let's first define some terminology in artificial intelligence. AI systems can be defined in 2 parts, in which I'll discuss, and then give you some examples to be able to understand how they relate to products you've heard of. So to start, GPU racks will be purpose-built to be either training or inferencing. For this, you'll need both to complete an AI system, and then training must occur before inference can be implemented. What training means is a developer feeds the model a curated data set so that it can learn everything it needs to about the type of data that it's going to analyze. And then you also have inferencing. Inferencing is the model creates output or predictions based on live data to produce actionable results. There's 2 things that are called that you'll hear in regards to AI. One is called Gen AI or generative AI that creates new content. Some examples can be ChatGPT or designs. You'll mostly see this with like chatbots. Many corporations are training customer service facing bots to be able to respond as first level customer contact points. Secondly, there's predictive AI, which uses trends to predict future outcomes in industries such as manufacturing, finance, and technology. An example of that is in technology, firewalls or IDS applications, seeing new types of hacking attacks, and then using AI to proactively disable the threat or alert analysts to the attacking process. So some of the trends we're seeing in the marketplace, you've probably heard of before. Power, cooling, and fiber density are beyond the capacity of most existing data centers. Most recently, Google and Microsoft announced deals for small modular reactors data centers that weren't built for AI and are quickly adapting their delivery methods to suit customer deployments by having to add cooling and power to smaller locations or pods. We've even seen new data centers with their own solar farms. So then you can actually expect most new data center builds to be designed specifically for AI. Power demand is driving the need for additional off-grid sources such as wind, solar, and SMR nuclear, which I mentioned that Google and Microsoft are looking at right now. Uh, the issue is retrofit is difficult as it requires large investments in power, cooling, and structured cabling in small areas like pods. Most large AI installs will be rack and stack done by integrators. These pods are not easy to build given all the constraints around cooling, power, cabling, and many are being purpose-built by these integrators. Enterprise customers are likely to only use one or two GPU servers per rack. Due to the power and cooling constraints that I just mentioned, some of these AI systems, enterprise-sized customers are having less GPUs per AI system just to make sure that they can have the power and cooling to be able to drive these racks. Smaller AI pods today are air-cooled, and we're seeing a trend of moving to direct-to-chip models as the density increases. This saves requirements to direct-to-chip cooling, which brings additional requirements to the customer's environment that might not be able to support today. This is why the GPU densities are smaller in some of these environments. And lastly, fiber use for all rack-to-rack and most in-rack connections. Factors such as cable diameter, distance limitations, and cable management make direct attached copper, active copper, and AEC cables an unattractive option. You'll see fiber predominantly used in AI connectivity. We're seeing customers using direct attach options having issues with cable management due to cable rigidity and the diameter of the cabling themselves. So the AI revolution is causing disruption in the data center marketplace. Starting in 2023 and going all the way to 2028, we're seeing a 4 times the spend on GPUs in the marketplace. This is creating a demand for GPUs that is outpacing the supply for it itself. When AI systems started becoming popular just a year or two ago, the spike on GPUs being sold to service technology went through the roof. We're seeing 10x more power needed per rack. As the density grows, so does the cooling need. DC providers were used to seeing their average server cabinet in the 5 to 14 kilowatt range. As you'll see later, 100 kilowatt per cabinet is not out of the question with these dense AI systems. And finally, we're seeing 4 times the cable density per rack, so meaning your cable management is going to be paramount in making sure that your installations are usable. With this density brings cabling issues, and as you'll see a little bit later, that transceiver trends is causing cable issues in AI as well. And Uptime Institute has actually predicted that 10% of all data center power in 2025 is going to be used specifically just for AI. And that's going to continue. So just to give you guys a quick comparison of the data center types that are out there, there's multiple out there. I'll give you a generalization of it. So we have enterprise, hyperscale, and AI data centers. I'd like to focus on some of the options like server connectivity. Traditionally, all the endpoints in hyperscale and enterprise data centers were terminated in duplex LC, as you're seeing here. With AI, we're seeing a lot more multi-fiber MPO-based connections at the end device itself. Also, if you gave me a bill of materials a year ago with a multi-mode angled polished connector on it, it would look like an outlier application. Now, rarely I see a bill of materials without one. Let's move down to protocol. So Ethernet has been the networking standard for 50 plus years. With the requirement of lossless connections and high bandwidth, InfiniBand is popular in AI applications. Obviously, as AI grows, the large Ethernet switch vendors like Cisco and Arista have created a consortium to tout the use of Ethernet in AI networks to not be left behind. We'll move down to power and rack considerations. So power, GPUs are power hungry, and 100 kilowatt cabinet is not unheard of in AI applications. As you see in the enterprise space here, 5 to 15 kilowatts is usually your average. If you move over to the AI marketplace, we're seeing upwards of over 100 kilowatts per cabinet. And then we'll move down to cooling. Most data centers were air-cooled and only liquid-cooled in very limited fashion. With AI, the smaller, less dense implementations are air-cooled, but we're seeing a trend on density, so liquid cooling will become the norm as we go forward. And lastly, let's move down to location. This one is actually pretty interesting. Often you'll find these data centers near large cities, which provide easy access to power and internet interconnection. With AI, we're seeing a trend of getting away from these populous regions because they're trying to tap large areas of unavailable power supply. We're even seeing new data centers buy offline power plants and turning them back on to suit power needs. Now that we've defined AI and went through some trends, let's discuss how this changes your cabling plan. So Nvidia, who's the market leader in AI, has published a 55-page guide on how to connect all of these components in an AI pod. The issue with this is everything is listed as point-to-point or direct connect cabling. Seeing that some of these pods can be 10 to 20 cabinets, what do you think cable management is going to look like when you're home running 30-meter cables like they're suggesting in their guide? Direct connect would only make sense for smaller enterprise installs where there isn't a larger pod or maybe 1 to 3 cabinets. These are the 4 fiber cable types that Nvidia suggests in their guide. Notice also that everything has a green connector housing. That designates that these cables are terminated in angle polish connectors that I discussed earlier in the guide. At these speeds, ensuring that you have less reflection and angled mating versus air gap connections can help with better performance. Notice the Y cables as well. This is for connecting 400 gig to 2 by 200 gig applications for those of you that might have seen these 2-to-1 breakout connections before. What I'm showing here is a layout of a SU or scalable unit rail optimized AI pod. This design is using 12 InfiniBand switches, 4 for spines and 8 for leads. The rail optimized design shown here is a mesh with one to all, which is different from legacy or primary failover networking. Rail optimized is a term that Nvidia uses to indicate maximizing performance while reducing any network interference. Key here is looking at the GPU server at the bottom. Each GPU has links to every link in the middle, and every leaf has an uplink to every spine up top. A full mesh. This diagram is just showing logical links too. A GPU NIC usually contains 2 fiber connections per 800 gig link using dual MPO8 400 gig transceivers. As you can see, this is going to start causing some cable congestion in your network. As I mentioned in the previous slide, here is that cable congestion. If you look at the transceiver in the bottom left, this is the most popular 800 gig transceiver in AI implementations. It uses 2 MPO8 cables running at 400 gig, and the transceiver is merging the lanes to bring that 800 gig throughput. What the picture up top is showing is a typical 64-port AI switch, or up to 128 MPO cables. This example is actually showing a Mellanox QM9700, just for reference. Remember, each scalable unit has 12 switches, 128 cables per switch going from GPU to GPU, GPU to leaf, or leaf switch to spine switch. The goal of AI is density. So what happens when you go from 1 pod to 4, these counts start ballooning. Just 1 pod, you can expect almost 800 fiber cables. Remember, that doesn't include out-of-band copper, liquid cooling lines, power cables. We're starting to get a good feel for what these AI cabinets are going to look like. Hopefully what I've been able to show you is what AI comes with a lot of challenges for customers and data centers alike. Being a trusted partner with world-class solutions, Panduit can help you with you or your customers' AI installs. We can do that by using the benefits of structured cabling. So what Panduit is known for in the connectivity space, among other things, we're a trusted structured cabling provider. Many recognize us as copper cabling company, but we've also been in the fiber marketplace for decades. What does structured cabling benefit you in AI installs? So 1, AI is a connector-rich, high dollar value cabling environment. As I mentioned, density is maximized, so there is no room for additional slack in cabling, and as well as slack may prohibit cooling of expensive infrastructure. Structured cabling also makes it easier to add a pod for growth. So now let's discuss the benefits of structured cabling. So if we look at the high cable density, I think I've shown that network longevity at 800 gig, you're not using OM3 patch cords. You're going to want to use OM4 or greater for all your horizontal links. We can skip down to the installation section here. AI brings you multiple points of connectivity. Think GPU to leaf to switch. And it sounds like a pretty good application need for structured cabling, if you ask me. So how does structured cabling look like in AI applications? Panduit has published a guide for how to complete structured cabling in AI environments. This guide is being used by installers and is being posted to Nvidia.com, showing Panduit as an approved structured cabling vendor. Here's what the guide showcases. We've defined the essential application types in an AI pod, which is switch to switch, GPU, etc., and highlighted structured cabling options for every connection in this guide. Multiple offerings based on application, as well as there's actually multiple offerings based on application, and it's also up to customer preference on which one you would want to use as well. To house the fiber itself, we have multiple options. HD Flex, as you'll see above, is an award-winning enclosure offering maximum density. SFQ QuickNet offering will offer you an ease of plug and play, and our Opticom offering offers slide out or tilt trays for ease of install. The connectivity can be completed with trunks or interconnects based on distance or customer need. Typically, if you're not pulling through fiber pathway and can lay in your cabinet to cabinet fiber in place, you can complete these installs with MPO fiber jumpers or interconnects, as we call them. So let's take a look at the guide. Each application will have a wireframe image shown up top, so you can visualize what the link looks like itself. Showcased here is an 800 gig switch to an 800 gig switch link. Each transceiver is using dual MPO interconnects to a fiber adapter panel, or FAP, with a structured connection of another interconnector trunk, then repeating this process on the far end to link that transceiver. Each application will show transceivers used, panel enclosure, and cassette options, as well as fiber interconnectivity to ensure you have a fully supported AI network link. This guide highlights 9 applications and what Panduit infrastructure you would actually need to cable it successfully in your environment. Lastly, let's discuss some products and applications that make Panduit a differentiator in the AI marketplace. So Rapid ID, all of our interconnects and patch cords come pre-labeled with Rapid ID labels. What this means for you at time of install, you can scan labels on both ends with the Bluetooth scanner into our software, give it the location of the to and from connection, and it will keep your connectivity map for you. So you can feel free to ditch your Excel spreadsheets now. Signature Core Fiber, so our patented OM4 Plus fiber that will enable extended distances in multi-mode applications, much that you're going to actually see in AI using multi-mode. Panduit is the only company on the market that will give you those extended distances beyond OM4 or OM5, often at 25 to 30% additional reach. Our Pan-MPO connector, another award-winning Panduit product that allows for field, gender, and polarity change without a separate tool. The tool is integrated into the connector housing and will aid in gender change. Did you order the wrong part? Or was it supposed to be male and you specified female? You can extend the pins in the field. If you ordered polarity A and you actually needed polarity B, this is also field changeable. Just remove the connector housing, rotate the connector housing 180 degrees, and you're good to go. Pan-MPO is also the same price as a standard MPO connector, so there's no reason not to specify it in your builds. Finally, HD Flex, it helps with dense applications. The nice thing about HD Flex is its split tray design, allowing you to minimize circuit risk by only sliding half a tray for any moves and changes. So these are some of the products that we offer in the AI marketplace and what you guys might be seeing when you're starting to spec some of the jobs for your AI customers or for yourself. Did I have any questions today, Kelly?
Okay, thank you very much, Mike. It does look like we have a couple questions in queue already. First one, why do you think 8 fiber angled polish connectors are more popular in AI than 16 fiber connectors, considering the high bandwidth nature of the application?
Good question. A few reasons, in my opinion, to be honest with you. For one, the better availability of 8 fiber connectors versus 16 fiber in the MPO form factor. 16 fiber isn't plug and play with existing 8 fiber or 12 fiber infrastructure either without some type of media conversion. There also isn't a lot of optical transceiver support right now for 16 fiber connectors. As well, the APC connector also helps with back reflection and signal loss, which is critical at these high speeds that we're seeing in AI. But as the speed and lane requirements increase, 16 fiber connectors will begin to become more popular in the marketplace, I think.
Okay, thank you. Second question, can't you just direct connect everything in DAC AOCs in AI?
So yes and no. So DACs work well in short distances with lower bandwidth applications. I would say 100 gig or lower. With AI, most applications are 400 gig or 800 gig. The distance limitations you're going to see, as well as the physical size and inflexibility, makes it a poor choice for cable management. And these connectivity dense applications like AI, and also having to pull AOCs from cabinet to cabinet for this application may break the cable, which would negate any benefit that you're actually getting from any AOCs.
Right, next question, what is the connectivity trend you're seeing for the next generation of AI?
Okay, so what we're seeing is some of the GPU manufacturers would suggest that simplifying your deployment with AEC cables or active electrical cables